Okay, so let us see, this is the problem, given problem. So we have a beam element having a point load of 20 kilonewton acting at the center of this beam. One side of the beam is fixed, another side is hinged, right? And this span is given as 500 centimeter and 500 centimeter, means this load is acting at the center. The next thing we have Young's modulus value and I value, everything they have given. Now, if you will see this problem, first step, what we need to do, we need to select the nodes. So how will you select the nodes? At the ends, we have to select the node, first one. This and this, these two are the nodes first. At the ends, we have to select the nodes. So these 2 points, we have selected the nodes at this point and at this point. Next one is, I have already discussed, at the point where there is sudden change in area or at the point where load is acting, we have to select node at that point also. It means we have to select the node at this point also, at this point. So let us take, this is node number 1, let us take this is node number 2, and let us take this is node number 3. So here this has converted into 3 noded problem, right? Since we have only one element, see, initially if you will see, you will say, sir, this is of one element only, because one side is fixed, another side is hinged. But since this 20 kilonewton load, you will see here, this 20 kilonewton load is acting at a point here, this, let us say at this point. So this point will also consider, we have to consider node at this point also. Okay, so we have 3 nodes. So automatically, if you have 3 nodes, so what will happen? This whole structure will divide into 2 parts, and this will become element number 1, and this will become your element number 2. So we have 3 nodes and we have 2 elements now. Element 1, element 2. Element 1 is between node number 1 and 2, and element number 2 is between node number 2 and 3. So next, what we need to do, we need to calculate the stiffness matrix, and then we will calculate the unknowns like F1, M1, and each and everything we will calculate. So let us take that V1, theta 1, F1, M1 are the unknowns at node number 1. So what I am taking? I am taking V1, theta 1, F1, and M1 are the unknowns at node 1. Similarly, V2, theta 2, F2, and M2 at node 2. And V3, theta 3, F3, and M3 at node 3. Okay, so we can represent this beam. Let us represent this beam, free body diagram. So how will you draw the free body diagram of this given beam? Let us take this. Okay, this is your node number 1, this is your node number 2, and this is your node number 3. At node number 1, we have vertical displacement V1 and we have force F1. So let us take, this is force F1, vertical displacement is V1, and this rotation, let us take, this is M1, and the slope is theta 1. Similarly, at 2, same we will take, and at 3, this is F2, this is F3. Here vertical displacement is V2, here vertical displacement is V3. Here we have to take a moment, that is M2, and the slope is theta 2. Similarly, at this point also, let us take the moment as M3 and slope is theta 3. This is the representation of the given problem. You can say free body diagram. Whatever the unknowns are there, we have represented that on this beam. Okay, so directly we will jump into stiffness matrix now. So already we have derived the formula for a stiffness matrix for a beam element. So we will use that. So here how many elements are there? 2 elements. So we will have 2 such stiffness matrices, K1 and K2. So first we are going for element number 1. So for element 1, for element 1, we are going to find the stiffness matrix. So the K1, let us take for element 1, the value of stiffness matrix is K1. That will be equal to E1 L1 upon, sorry, E1 I1. Sorry, this is E1 I1 upon L1 cube into, already we have derived these things, 12 6L minus 12 6L, again here 6L 4L square, here it will be minus 6L, here it will be 2L square, then we will have minus 12 minus 6L, then 12 minus 6L, and then 6L 2L square minus 6L 4L square. So this is the stiffness matrix K1 for element number 1. Now what we need to do, we need to put all the values because we have all the given values. L value is given 500 centimeter, L1 is nothing, 500 centimeter only. E1 value is given, I1 value is given, because E1 and I1 is same for both elements, right? So E1 into I1 upon L1 cube. So here we have E1 value, we have I1 value, and we have L1 value. This is L1 and this is your L2 value, right? So L1 value is 500 centimeter. If you will put each and everything here, you are going to get it as 400. Let us take this at 400 outside. Now remaining thing we will put inside means L value 12. So we will have 12 here, 6 into L. So 500 centimeter, right? So 3000 minus 12, again 6L, so 3000, again 6L, so 3000, because L is 500. Already see here, we have L value as 500 centimeters. So just we have to multiply it, right? So 4L square. So 4L square will be 500 into 500 into 4. So this will be 10 to the power 6 minus 3000. Here 5 into 10 to the power 5. Here it will be minus 12 minus 3000. Then 12, again minus 3000. Then we will have 3000. Then 5 into 10 to the power 5. Then we will have minus 3000. And then we will have 10 to the power 6. So this is our K1 value. Nothing, just it is easy itself, right? Nothing we have to do, only we have to put this value, simple calculation. Now K1 value, we have calculated K1 value means for element number 1. So element number 1 is between node number 1 and 2. So what are the displacements here? The displacement is this F1 and M1 is the force, right? What is the displacement? Displacement is nothing here. At 1, the displacement is V1 and theta 1. At 2, displacement is V2 theta 2. And at 3, displacement is V3 theta 3. So we can write here, we can give displacement. If we will see, this will be for V1, then theta 1, node 1, node 2, V2 theta 2. This I am talking about rows, right? Similarly, we can write here, this column belongs to V1, this column will belong to theta 1, this will be for V2, and this will be for theta 2. This talking about these columns. Just I am marking these things so that when we are going to calculate the global stiffness matrix, it will be easy for us to calculate, right? Now we will calculate the stiffness matrix for element number 2 also. So what do you think? Will it be different or will it be same? Because each and everything is same for element 2 also. If you will see here in the problem, For element 2, length again 500 centimeter, E value 20 into 10 to the power 3, I value 2500. So each and everything is same. So we will get the identical stiffness matrix. For element number 2 also we will get the same stiffness matrix. Okay, so directly I will write, because we have already calculated, so I am going to write directly K2 value also. So K2 value is also getting, we are going to get this same value. So directly I will write for element number 2, for element 2, we will have K2 value. So K2 value will be equal to 400, right? As it is, we have got the values already, we have the values now. Then we will have 12, then 3000 minus 12, 3000, again 3000, 10 to the power 6 minus 3000, 5 into 10 to the power 5. Then we will have minus 12, minus 3000, then we will have 12, then minus 3000, then we will have 3000, 5 into 10 to the power 5, then we will have minus 3000 again, and then we have 10 to the power 6. So we have already calculated K2 value also. Now we will mention the displacements here. See, element number 2 is between second node and third node. So second node means V2 theta 2 and third node means V3 theta 3. So we will write it here. This will be V2 theta 2, V3 theta 3. Here also V2 theta 2, V3 theta 3. Now we will calculate the global stiffness matrix. Now we are going to calculate the global stiffness matrix. So next we are going to calculate global stiffness matrix. Stiffness matrix. What is global stiffness matrix? Global stiffness matrix is nothing, the combination of individual stiffness matrix of the elements, right? So it is nothing K1 plus K2. So we are going to get now K matrix for whole element, that is the given beam. So we will calculate the global stiffness matrix. Now coming to global stiffness matrix, first we will see this given beam. How many nodes are there? 3 nodes. So how many displacement will be there? 6. V1 theta 1, V2 theta 2 and V3 theta 3. So let us write that first, so that it will be easy for us to identify what we need to write here. So here this row will be, column will be V1, then we will have V theta 1, V2, theta 2, V3, then we will have theta 3. Again, so let us write here again V1, theta 1, V2, theta 2, V3, theta 3. Now we need to fill this by seeing K1 and K2 value. How we will fill this? Let us see. Now first element here, the first element will be V1 element. Just see the column and just see the row number, right? This is V1 column, V1 row. So whatever the element is there, V1 column, V1 row, that we need to write here. So let us see, where is V1 in this element number 2? There is no V1 term, right? So here there is no chance of getting V1. Here we will have V1 and V1. So see here V1. We have element. What is that? That is 12. This is the element, right? V1 element is 12. So we will fill it there. Here it will be 12. Now next, theta 1 V1. So where will be theta 1 V1? Here is there is any theta 1? No. Theta 1, yes. V1, yes. So what is the element? 3000. So we will write there 3000. This is very, very important. If you understand how to calculate the global stiffness matrix, the problem is solved. Nothing is there then. Now V2, V1. Coming to V2, V1. Is there V2? Yes. But is there any V1 term here? No. We need to see the row. See here, V2 is column, V1 is row. So we need to see V2 column, V1 row. So see, V2 column is there, but there is no V1 row, right? So there will be no such term. But here V2 is there, V1 is there. So what is the term? Minus 12. So let us write here minus 12. Similarly, theta to V1 again we will get here theta to V1 is 3000. So let us write 3000. Now V3 V1. Let us search V3 V1. Is there any V3 term? No. Okay. There is no V3 term, right? In column, is there any V3? No. Next, in K2 we have V3, but in row there is no V1 term. Means there is no such element. V3 V1 element is not present either in K1 or in K2. So directly that value is going to be 0. Similarly for theta 3 also it is going to be 0 only, because for theta 3 V1 also there is no such element is K1 nor in K2. So 0, 0. Next, V1 theta 1. So again we will come to see there is no V1 term is K2. So there is, so why we need to see K2 again? Because directly we will find that value in K1. So there is time waste of seeing K2 also. So directly we will jump here. V1 theta 1 3000, then 10 to the power 6. So let us write 3000. Then directly we can write 10 to the power 6. Then V2 term will be there only, again minus 3000. Then we will have theta 2 term 5 into 10 to the power 5. And again V3 theta 3 in terms of theta 1 will not be there in either in K1 or in K2. So directly it will become 0. You can see here, you will not find V3 theta 3 terms of V1. V3 theta 3 is there, no V1. Here V1 theta 1 is there, but V3 term is not there. V3 theta 2 is not there. Theta 3 is not there. So 0. Next we have V1 V2 term. So V1 V2 term. Again, whenever we are talking about in column V1 theta 1, it will be in K1 only. It will be in K1 only, V1 theta 1. There is no such term in K2, right? So directly whenever we are talking about V1 theta 1, we will see the K1 only. So here minus 12 minus 3000, right? So directly we can write minus 12 minus 3000. Minus 12 minus 3000. Okay. Then again here if you will see V2 V2. Now we'll come for V2 V2. Where we will have V2 V2. See V2 and V2. We have this 12. See V2 V2 12. Similarly we will get here also V2 V2 12. So we will add 12 plus 12. What will be that value? 24, right? Either else you will write 12 plus 12 or directly we can write 24, because 12 plus 12 will become 24. Again theta 2 V2. So theta 2 V2 will be in K1 also, and it will be in K2 also. See theta 2 V2 3000 here, and here the value is minus 3000. So minus 3000 plus 3000, the value is going to be 0. Next term is V3 V2 minus 12. So directly we can write minus 12. Then theta 3 V2 is 3000. So directly we can write 3000. Similarly, we need to see that, remember K1 is related to V1 theta 1, V2 theta 2. K2 is related to V2 theta 2, V3 theta 3. So whenever we will have V2 theta 2, we have to be little bit careful because it will be in K1 also, it will be in K2 also, right? Otherwise, V1 theta 1 terms and V3 theta 3 terms will be, V3 theta 3 will be in K2 and V1 theta 1 will be in K1 itself. You can see that values of K1 and K2 also. So if we'll continue the same thing, so we can write V1 theta 2. So it is 3000. Next, it will be 5 into 10 to the power 5, right? So here again, V2 theta 2, V2 theta 2 say V2 theta 2, 3000, and in K1, V2 theta 2 minus 3000. So 3000 minus 3000 is going to be 0. Similarly, if you will add 2 into 10 to the power 6, because here it will be 10 to the power theta 2, theta 2. Let us see theta 2, theta 2, theta 2, 10 to the power 6. And in K1, we have theta 2, theta 2, 10 to the power 6. So 2 into 10 to the power 6. Next, V3 theta 2. So I am going to write it now directly. Just you have to repeat the same steps and you have to find the global stiffness matrix, right? Again, we will have 0, then we will have 0, then we will have minus 12, then we will have minus 3000, then we will have 12 minus 3000, and this theta 3 terms 0, 0, then we will have 3000, then we have 5 into 10 to the power 5, and then we have minus 3000, and then we have 10 to the power 6. So we have calculated all the values. See, 1, 2, 3, 4, 5, 6. We have calculated the global stiffness matrix. This is our global stiffness matrix. Once we got the global stiffness matrix, we can find whatever unknowns are there, we can find. And yes, we forgot to write here 400 because that 400 is in outside, right? This 400. So 400 is here. Don't forget this. So 400 into the given. This global stiffness matrix, I hope you understood how to calculate the global stiffness matrix by seeing the elemental stiffness matrix, K1 value and K2 value. Once we got that global stiffness matrix, what we need to do? We have the equation. We know F is equal to K into delta. So just we will apply this. F is equal to K into delta. We will get the remaining unknown. So F is equal to K into delta. So what are the forces? Forces we have already. We have taken that forces F1, M1, F2, M2, F3, M3. So what are the unknowns? What are given values already in the question? See, F1 is unknown, M1 is unknown, F2 value is given. What is that F2 value? See here, F2 value is already given, 20 kilonewton. Which direction? Downward direction. Downward direction means we have to take negative. This is at second node, right? So this is your F2 value. So F2 value is 20 kilonewton. So let us write whatever the value is given, then we will put here. So here we have V1 is equal to 0. Why V1 is 0? Let us see. This is fixed. Node 1 is fixed. So V1 will be 0. Vertical, there will be no vertical displacements, right? Similarly, theta will also, there will be no slope also, right? Theta 1 will also be 0 because I have already said whenever there is a fixed support, the displacements are going to be 0. So at node 1, V1 will be 0, theta 1 will be 0. In the question, they have given V3 is also 0. In the question, they have mentioned that V3 value is also 0. From the question, we can write F2 value is, we have to write it in Newton. So minus, because it is acting downwards. So 20,000 Newton, 20 kilonewton. So kilo we have converted into Newton. So minus 20,000 Newton. In question, they have given M2 value is also 0 as well as M3 value is also 0. So these are the things they have given in the question. These two things we have analyzed, these three things, this thing, and this we have analyzed by seeing that figure, and remaining things they have mentioned in the question. So let us write now. So what will be the force? Force F1, M1, then F2. F2 is already we have minus 20,000. Then M2, then F3, M3. This is the global, or we can say load vector into that stiffness matrix 400. We will write the stiffness matrix, and then we have displacement matrix delta. In the displacement matrix, what are the displacements? Now we have displacement at node number 1 v1 theta 1, node 2 v2 theta 2, node 3 v3 theta 3, and we have that matrix already. We have derived that matrix, calculated that 12, 3000 minus 12, 3000, then 0, 0, then again we have 3000, 10 to the power 6 minus 3000, 5 into 10 to the power 5, then we have 0, 0, then we have minus 12 minus 3000, then we have 24, 0, minus 12, 3000, then we have 3000, 5 into 10 to the power 5, then we have 0, 2 into 10 to the power 6 minus 3000, then 5 into 10 to the power 5, then we have 0, 0, 0, then minus 12, sorry, minus 12, 3000, then we have minus 3000, 12 minus 3000, then we have 5 into 10 to the power 5 minus 3000 and 10 to the power. Okay, so we have these values now. V1 value is 0, theta 1 value is 0, and then we have V3 value. V3 value is also 0. So we know if any value of displacement is 0, according to boundary condition, we will remove the corresponding row and the corresponding column in the stiffness matrix. So we will remove this. For calculation purpose, we need to remove this. Similarly, this is at node number 1 V1, so we will remove this also. Next, theta 1 is 0, so again second row, this we need to remove. Similarly, second column from here. Then V3 is 0, right? So this term is going to be removed. Similarly, which one is this? 1, 2, 3, 4, 5. Fifth one, right? So 1, 2, 3, 4, fifth column is going to be removed. So this we have the reduced matrix now. Now, if you will see what is the size of the reduced matrix, we have 1, 2, and 3. 3 by 3 matrix will be there. So just we need to write the reduced matrix now. So let us write the reduced matrix. The reduced matrix is in the form of, yes, one more thing. Let us see one more thing here. Here M2 value is also 0. M2 value is 0, M3 value is 0. So M2 value is also 0, M3 value is also 0. So in force matrix, we have minus 20,000, 0, 0. So let us write minus 20,000, 0, 0. This is the force vector. Then 400 into. Now let us see 24, 0, See, 24, 0, 3000. 24, 0, 3000. Next, in front of M2, 0, 2 into 10 to the power 6, 5 into 10 to the power 5. So let us write 0, 2 into 10 to the power 6, 5 into 10 to the power 5. Now, again here, last one, 3000, 5 into 10 to the power 5, 10 to the power 6. So let us write 3000, 5 into 10 to the power 5 and 10 to the power 6. And remaining displacements are let us see the remaining displacement. V2, theta 2, theta 3. V2, theta 2 and theta 3. So we have this reduced matrix. Now from here we can write the equations. So first we are going to write the equation for V2. So what will happen? This 24 into V2 we can write from first one. From here we are going to write the equation. So we can write 24 into V2, 0 into theta 2 will be 0 only, right? Plus 3000 into theta 3 plus 3000 into theta 3 is going to be equal to minus 20,000. This is equation number 1. Similarly, we are going to write equation number 2. Yeah, here we will have 400 outside because 400 is common, right? So again, from second, we are going to get 0 into V2, 0, 2 into 6 into theta 2. So just we will write 2 into 10 to the power 6 V2, sorry, theta 2. Theta 2 plus 5 into 10 to the power 5 theta 3 is going to be equal to 0 because this is 0. This is equation number 2. Now equation number 3, again 400 outside, 3000 into V2. So 3000 V2 plus 5 into 10 to the power 5 theta 2 plus 10 to the power 6 theta 3 is going to equal to 0. This is equation number 3. We have 3 equations, 3 unknown. So we can solve this and we can get the value of V2, theta 2 and theta 3. So on solving these 3 equations, we get the value of theta 2 as, we get the theta 2 value as minus 0.003125 radian. Just you have to keep the values in your calci, you will get these values. Theta 3 values 0.0125 radian. And then we have V2 value as minus 3.646 centimeter. So we have calculated all the unknowns. Now what we need to calculate? We need to calculate, see, whatever the non-zero forces are there, non-zero forces is F1. F1 is not equal to 0. So we need to calculate F1. Since we have removed this as V1 is 0, but F1 is not 0, right? Here you can find there is no such thing that F1 is 0. Even M1 is also not 0. Even your F3 is also not 0. So we need to calculate F1, M1 and F3. F2 value, you know, M2 value already given 0, M3 value already given 0. So we need to calculate F1, M1 and F3. So we know all the values. By putting that, we can calculate F1 also, F1, F2, F1, M1 and F3. So let us calculate F1 now. So F1 is equal to 400 into minus 12 V2 plus 3000 theta 2. See how we got this from the main stiffness matrix here. F1 can be written as 12 into V1. V1 is 0, so 0. 3000 into theta 1, 0, so it will be 0. Minus 12 into V2, 3000 into theta 2, right? and V3 is again 0, and this term is again 0. So if you will multiply, you are going to get from here, see, minus 12 into V2, 3000 into theta 2, and remaining all the terms is going to be 0 is equal to F1. Yes, 400 is outside, so 400. So same thing I have written here. 400 minus 12 V2 plus 3000 theta 2. V2 value you know, theta 2 value you know. Once we will keep this value, we are going to get F1 value. So F1 value is nothing, 13750 Newton. Similarly, I am writing because the same way we have to calculate the other one is also M1 value will be 400 minus 3000 V2 plus 5 into 10 to the power 5 theta 2. So we will get M1 value as 3750200 Newton centimeter. Again, we have now F3 value. So F3 value will be 400 into minus 12 V2 minus 3000 theta 2 minus 3000 theta 3. So once you will keep, you will get the value of F3 as 6250 Newton. That's it. These are the unknowns what we need to calculate. So just they will ask you the final results in a proper manner. What are the displacement at node 1? So node 1, V1 is 0 and theta 1 is 0. Vertical displacement only we have V2 value. V1 and V3 is 0. Nodal slopes, theta 1 is 0. Theta 1, theta 2 and theta 3 value we have, right? So out of 6 displacements, we have only 3 displacements, remaining 3 displacements are 0. Okay, so this is the problem. So we have calculated each and everything. Here M1 value is there and remaining values for moments they have given M2 value 0, M3 value. So only we will have moment M1. Okay, and then force, if you are talking, we will have F1 value, we have F2 value, and we have F3 value also, means all 3 values are there. So this is the thing we need to calculate. We have already calculated all the unknown displacements. We have already calculated all the unknown forces. Yes, if they can ask the shear force diagram also. So shear force diagram is nothing. Already we have calculated F1, F2 and F3. These are shear force only, right? So you can draw this. This is your node number 1. This is your node number 2. This is your node number 3. So F1 value is 13750. So 13750. We can write here 13750. Then your F2 value. F2 value is minus. F2 value is given, right? See here, F2 value is already given minus 20,000. So minus 20,000 we will draw here, here, and again we will come minus. So if you will subtract minus 20,000 from here, we are going to get as minus 6250. And then again F3 we have 6250, right? So again it will come to in positive direction. So we'll go here. That's it. This is plus and this is minus. This is your shear force diagram. SFD, shear force diagram. This will be F1. This is here F2. And this is here F3. Shear force diagram. If they are asking bending moment diagram, so we know bending moment diagram at. If you want to draw the bending moment diagram also, let us take at node number 2 and node number 3. Bending moment diagram is 0. Only we have M1 value. See, only we have M1 value. We have M2 and M3 as 0. See, M2 0, M3 0. So how will you draw the bending moment diagram? Directly, M1 value is this much. So let us take 3750200. And then directly at node number 2, it is going to be 0. Let us take this as node number 2. Okay. And again, it is going to be same 0 only till node number 3. So this is your bending moment diagram. That's it. This is the maximum situation, maximum what they can ask, shear force and bending moment diagram. But mostly they will ask till here itself. Okay, so our problem is completed. In next class, we will discuss a problem on continuous beam, how to approach this problem. Approach is same, only we will see one problem so that it will be helpful for you. Okay.